In that last video, you might be wondering how it was that I actually managed to expand the brackets in that problem so quickly and easily. And that was just, I used something called Pascal's triangle. So Pascal was a famous mathematician who did a lot of things in a lot of different areas of maths. But I think that his triangle is just one of his masterpieces. And Pascal's triangle looks like this. So it starts off with a 1 at the top, and then it has 1s down the diagonals of the triangle. So we would have 1 and 1 here, and then we would have 1 and 1 here. The number that goes here is 2. And then the next row goes 1, 3, 3, 1, and then 1, 4, 6, 4, 1, and so on. So the pattern being that the sum of the two numbers above form the number below. So 1 plus 1 is 2, likewise 2 plus 1 is 3, and 3 plus 3 is 6, and so on. So this is Pascal's triangle, and this goes on forever. But the thing is, the numbers here correspond to the coefficients in binomial expansions. So if I had, for example, x plus h squared, then I would be using the row that has the 2 in it, okay, because it's a squared problem, and the solution would simply be x squared plus 2xh plus h squared. So the coefficient of the x squared term is 1, coefficient of the next term is 2, and then the coefficient of the term after that is 1 again. And we can see that 1, 2, 1. If instead I wanted to expand x plus h to the power of 4, then I could use this row here. So I know that it's going to become x to the power of 4 plus 4x cubed h plus 6x squared h squared plus 4xh cubed, and then plus h to the power of 4. So really quick and easy to do. I'm going to write up one more, and what I would like you to do is to pause the video and actually have a go at doing it for yourself. You might need to add a row to Pascal's triangle or two, but just see how you go with it. So the next one that I'd like you to do is x plus h to the power of 6. So anyway, pause the video now, and I'll do the answer in just a second. Okay, so I hope that you paused the video and had a go at that. What I'm going to do is I'm going to add in a bit more information here. So it's 1, 5, 10, 10, 5, 1. And then the one that I need is going to be 1, 6, 15, 20, 15, 6, 1. So those are going to be my coefficients. So it's going to become x to the power of 6 plus 6x to the 5h plus 15x to the 4h squared plus 20x to the 3h to the 3 plus 15x squared h to the 4 plus 6x h to the 5, and then plus h to the power of 6. There we are. What you can see is happening here is that the powers are gradually transferring from the first term onto the second term. So, for example, we started off with the power of 2 here. This power decreased by 1, the power of h increased by 1, so we had a power of 1 on each. And then the other power from here transferred across to the h, meaning that h had both of them. And it always starts off this way. So the 4 becomes a 3 and a 1, and then that becomes a 2 and a 2, and then a 1 and a 3, and then it's all 4 over on the other term. So the powers are gradually transferring across in these kinds of problems. Anyway, I'll leave it there, and we'll see you next time.